Hi guys, today I'm going to talk about the reaction of diazonium salt. But before we go through the reaction, we have to understand the preparation of diazonium salt. So how to prepare it? So this is the diazonium salt. So to prepare it, we will have the HCl react with NaNO2, and this is two equivalent, we'll talk about it later, to form the HNO2 with NaCl. So this is what we want, the HNO2, specifically the nitrous sodium ion, NO+. So this is how it works. First of all, the NaNO2, specifically the oxygen, negative charge by the oxygen, one of the oxygen that has single bond between the N, and it will grab the proton or the hydrogen and give the chlorine a negative charge. And then after that, another equivalent of HCl will be protonated this oxygen. So after that, we'll form a OH2 with a positive charge, which is a good leaving group that leaves the H2O, and hence we'll get these nitrogen ions. And this is the overall reaction. And after we have this nitrogen ion, we can react it with the aniline to form a diazonium salt. So how it works is the nitrogen from the aniline will attack the positive charge of nitrogen ion, and then they will form a bond at here. So after that, the positive charge will be balanced by the hydrogen, so we'll have some sort of base whatsoever. There's plenty of base in that reaction. So the base acts as a proton acceptor, so it grabs a proton and the electron gives to the nitrogen from this structure, which is known as the nitrosoamide. And then it can donate its electron to this bond to form a double bond between the nitrogen, and this pi bond from NO will attack the acid. So we know that this reaction occurs in the acidic condition, so we have plenty of acid. And after that, it will react with the acid or grab the hydrogen, and the electron will give to the halogen. So we'll have this negative charge. And then after that, this negative charge will further grab the hydrogen from the nitrogen again to reform the HX. So just now at first the oxygen grabbed hydrogen. Now is the X, which comes from the acid. So the NiN will grab the hydrogen not from the oxygen but from the nitrogen, and that gives us this compound, which is known as the N-hydroxy azo compound. So azo means an N and hydroxy means OH attached at one of the N, and that's why it's called N-hydroxy azo compound. And then this reformed acid is used to protonate this OH to form a OH2, which is a good leaving group, giving us the final product, diazonium salt. And the diazonium salt could go through two types of reaction. The first type will be the decomposition when heat is given up, and the second type is the electrophilic substitution reaction by the alkoxide aromatic rings when the temperature is low. So let's look at the decomposition first. Very easy. SN1 reaction, which means that there will be leaving group, a good leaving group, which is this N2, and then leaving a carbocation ion, secondary carbocation ion, and the water will attack the carbocation ion to form a OH2 positive charge. And then one more water is going to simply just deprotonate the oxygen, leaving the phenol. So the side product will be N2. And now let's look at the cold condition. This is a bit more complex, but generally will react with the alkoxide ion generated from the acid-base reaction, and then it can form a resonance structure, which typically the para position is more favorable than the auto position, and that's because the electron repulsion force is smaller, and hence it could attack this nitrogen, giving balancing the adjacent nitrogen positive charge, and hence giving us this compound. But this is not N yet, because as you can see here, the benzene ring is still not stable. So what it will do is this hydrogen will give its electron to the bond to the aromatic ring structure to reform a benzene ring structure, which is favorable, and hence leaving the oxygen negative charge, and therefore it will be protonated by the acid, since we are doing it in acidic condition, to form an azo compound. So if you look through the types of azo compound, we have various types, but the concept is the same. So generally, this diazonium salt um, will be similar, at least I would say. So just recognize this structure, then you should be fine. But the difference lies in the substituents you use in the reaction. So different substituents will give different color. So that's why we have so many color that actually are made of the diazonium salt, which is known as the azo compound. That's all for my presentation today. Thank you.